Hi explorers, and welcome to another video. Today we are going to talk about Tacotron.
First off, before I start to talk about Tacotron, I really need to thank Linda Johnson, which you heard before in the intro here. She actually spent more than 24 hours in a recording booth recording different audio snippets in order to create a data set that I could train with and create this sound. So a huge thanks to her open source contribution with her voice, reading a lot of material. So we are going to talk about Tacotron, and Tacotron is a tool where you can run a neural network with a lot of texts and trying to find how to convert this text into speech. Linda is one of the contributors, but there is also some M labs that have a lot more. I think they have 700 hours of speech on 10 languages. So there is a lot of speech out there that you can use to train your model. So what I try to train here is this little phrase here. Hello, hi explorers, and welcome to another video. You see here that I added an extra D in order to make that sound a little bit more natural, or either she would have said video, and I thought that sounded a little bit off. Today we're going to talk about Tacotron. I'm not sure if you thought that it was good or if you thought it was really bad, but I think that as voice synthesists, it's pretty decent, and I have trained the Tacotron part of this network for about, let's say, 3 weeks or something. And there is actually a Wavelet that you can use on the Tacotron result in order to improve this even more and get a more natural speech. And that took me a month or a little bit more than a month to actually train, and I thought the result was not as good, so I have scrapped that, and I'm trying to work around and get it to be even better. So how do you use Tacotron then? This is Tacotron 2, so it's with Wavelet, and it's a TensorFlow implementation of DeepMind Tacotron through a deep neural network architecture described in this paper. So if you want to read about it, you can read about it here. And then they described some structure here. First off, you have some data set structure for the M labs, and then you have this LJ speech, which is Linda Johnson's speech, and you will get an logs output Tacotron. This is the output from the training of the Tacotron model, and then you have an output of the Tacotron Wavelet training. You will have some models here, so, and output from the actual synthesis and evaluations of the modules. And then we have the training data, and this training data will become quite huge because you take some speech and then you will create some NumPy data that you will use in your training, and these are large. I think that on my hard drive at the moment they are about 30 gigabytes, and all in all I think everything here is about 110 gigabytes or something like that, and that's from a sound sampling of 1 gigabyte becomes 30 gigabytes. So if you download the I think it's 30 or 50 gigabytes, no, 80 gigabytes of training data from M labs here, MI labs, then you will have a lot of data that you need to sift through, and it also requires a lot of GPU to actually train your model. So how do we do this? We get a data set, either Linda Johnson's speech or the MLabs. We pre-process the data, so we get the training data folder, which is large. I actually ran into having too little hard disk space. I had to move the whole project. And then you train your model, you synthesize and evaluate that, you train your Wavelet model, and you synthesize the audio and test that out as well. Pre-trained sample and model can be found here. I didn't look at that at all. I wanted to try it out to train it myself. This is the architecture. You can look at this if you like. You can see here that I have some character embedding, which goes into a 3 layers convolutional layer network with a bidirectional LSTM. So that's long short-term memory. Yeah, long short-term memory. And then you have this little thing over here, and then it goes into the Wavelet thing over here. So it's quite an involved network. And we start by running this requirement, so it will download a few Python dependencies, not that many. It won't take that much time, and you need to set up your hparam settings. I'm going to go through that file. There is a lot of settings, and you don't need to know all of them, but some of them I will highlight, which are good to know. Pre-processing is done like just running the pre-processing step if you are using the Linda Johnson data set, or you will need to add a lot of parameters if you're using the other, because you need to say that you want one of the voices, you need to tell it what language and which reader and which book, or if you want to merge all the books and read everything. And this should take no longer than a few minutes. The Linda Johnson took about a half an hour, so a few minutes is a little bit misleading, I would say. But I guess it depends on what kind of computer you have. And then you can train either both of the models, or you can train one model, either Wavelet or Tacotron. It will save checkpoints every 5,000 steps, and then do an evaluation after 10,000 steps. But you can add a variable to actually say that it should save every 1,000 steps, and I did that because training, and if you need to break the training somewhere, you don't want to lose 4,900 steps. That would be quite sad. So adding a variable to actually tell it to save a little bit more often. I think the training data is about 300 megs a time, so those are not super huge. So I think saving a little bit more often will save you time in the end. And then we have the synthesis, and this is just running the module and getting some result out, so you can listen and see what you think about your training. So it's pretty straightforward. I downloaded the master branch somewhere in the middle of the works. I needed to go into some of the scripts and remove some variables that was not required and was added faulty, so it didn't run at all. But I think if you are downloading a specific version or a branch that is more of a release branch, you will not encounter those problems. But I wanted to have the bleeding edge, and then sometimes you need to actually do some tweaking to get things running. So if we look at the hparams here, you first need to specify which language or which cleaner you want, and this is something that goes through and removes some things from the data set to to ensure that it's clean. So it's let's say if you have a lot of special characters in your training set, or you have characters that don't actually sound, you just write them because they have a meaning in text but they don't have a meaning in sound, then you will clean those out. So this is to prepare the training set and remove such characters. The quotation signs, for instance, those are there to bring meaning, and perhaps you will read that section a bit different, but when you create sound, they don't actually make a sound. And then you have some audio settings here. I don't really know what all of these actually mean. Then we have this very strange LVS, and it was not recommended to run this if you did Wavelet, so I just turned this off. Then we have some MEL spectrogram things here. And the important thing to look at here is the sample rate, because when I create my sound later on, I want to bunch a bunch of sounds together. So if I encode each sentence, then I want to put them together with a little bit of silence in between, and to do that you need to have the same sample rate of your silence as you have on your actual training set. And then we have some trims, don't know. We have MEL spectrogram normalization, scaling and clipping, don't know. So there's a lot of parameters, a lot of things you can tweak on here. Everything here is something that I haven't touched, it's just as it is. A lot of things, as you see. Then we come down here to the Wavelet, and in order to run Wavelet, and Wavelet's training is the hardest part. The Tacotron training went just fine, and also synthesizing that was just fine, and if you're using the linear sound files, it sounds quite good, as you heard in the beginning here. But running the Wavelet, that was where I encountered a lot of problems, and I got it to run if I ran it in input raw. I tried Moolah and Moolah quantize as well, but when I did that, I actually got the weird result of having a loss rate of a minus value. So if you're starting from a big value and then trying to make it smaller and closer to 0, I don't really know how you should evaluate a value that starts on minus 50. It just don't make sense. So I didn't get those working at all. Quantize channels, can try to write either 16 bits or 8 bits. I've tried both. 16 is preferred, I would say. Out channels here, they actually set that to 2, but as you see here, to Gaussian distribution as output distribution instead of a mixture of logistics, set output channel to 2 instead of out channel 10.3 under test. So they're actually running some tests in this repository, and I set it back to the old value, and that worked better. But it still says that you should have number of distribution times 3, and I didn't really know what number of distribution was. I didn't find that value, but as they used 10 in earlier, so I reset it to that. One thing here I found today was upsample activation Leakerello. Never heard of Leakerello before, but you can actually run with the standard Rello if you like. So I'm gonna try that in my training later and see if I get a better result. But because I think that my Wavelet, when I train it, it took a lot of time and I didn't get a good result. So maybe this is to blame. Maybe I should try a little bit less of a Leakerello. And then we have max steps here. This I changed a little bit. As you see here, they recommend 8,000 to a modest GPU and 13,000 to a stronger one. I think I have a pretty good GPU, but I still had to move it down a bit in order to actually get the model to fit inside of the GPU memory. I'm not sure, but I think this script or this training set should require something like 16 gigabytes of memory on your GPU or 32. I only have 8, so I'm a little bit hampered there. Another thing I had to change was the batch size. I think it was 32 or 64 before, but I had to tweak it down to 16 in order to get it to run. One thing you need to look into then, if you change that, you need to also change down here. So these are connected. So 16 times the batch size, and the batch size you have up here. So you need to change both of these values. Important. And then we have some start decay and learning rate and so on. I haven't changed these. These seems very reasonable. These beta 1 and 2 values and epsilon is actually standard values for the Atom optimizer, so I didn't see any reason to change those. Same goes for the dropout zones. Natural eval sounded really fancy when I looked into this, but I don't really know what the teacher forcing ratio is, so I'm not going to use that one. And then you have a lot of setting for these teacher forcing mode, but there is a paper, so you can read about that if you want to try that out. Wavelet training is very similar. I tried this swap with CPU because I thought my GPU was too weak, so I tried to run with a little bit more of CPU. It took forever, so get a better CPU GPU if you want to run this. Don't even try this. It's not worth it. I had to change this batch size as well. I think that was 32 before. Now it's 8. And then we have the same as with the Tacotron setup up there. We have some Atom. We have some learning rates. And clip gradients, I turned that off. And train with GTA. And this is something that creates GTA melts from the one of the ground truth activations from one of the modules, so the Tacotron model, so you can turn them over to your Wavelet module. So if you turn this on, you have a connection between those. But as I said before, I didn't really get my Wavelet to train correctly and actually get a better sounding result afterwards. I need to still tweak these variables a bit and try even more things. But I think I've been tweaking and trying things out for 4 months now. So I'm pretty happy with the result I've gotten so far. But I have more work to do. And then I created this little fun script here just to take text and create an output. I first off remove all the old evaluation waves, and then I will run the synthesize with the model of Tacotron on a text file of choosing. And this text file looks like this. You have one row for each sentence, and you can have as many sentences as you like. And then I create this little silence, so a piece of silence for 1 second, and then I will run SOX and loop over all the waves with a linear. So you have MELs and linear waves. The MELs are used for the training of the Wavelet, but the linear are the result that sounds better. So if you want to use them right off the bat, that's what you want. And I want to sort these in a natural order. So LSV will give me a natural order, or else I will get 10 before 1, because 10 is also 1, but 0 is larger than a dash or whatever. It comes after. Dash comes after, before the linear here. So I needed to sort them in a natural order. I loop over these, and then I output the file plus the silent wave. So this will give me a long list of files to concatenate together with the silence in between. And then I end up with an output, which is the other file name here. So that will create a file with continuous sound, so you can hear what actually is recorded. You can listen to a little bit of a longer speech here.
Action by Katie Reilly, long before it opened in U.S. District Court in Boston on Oct. 15, the trial over the use of race in Harvard University admissions.
So you hear that it sounds very natural in the speech, and I really like this little project. It's easy to run, a lot of things to tweak if you want to play around with it. It got me really geared up, and I can really see things that you can do with this. Training takes a lot of time, but actually synthesizing a sound like the one I used in the intro of this took about, let's say, a minute, and that's with the startup time and concatenation and everything. If you are doing a longer thing, so let's say that you're doing a full article from a blog or something, that might take you 50 minutes or something, and then you have speech that you can listen to. So this is what I wanted to talk to you about today. I hope that you found this interesting. I hope that you want to try this out. I will leave a link to the actual project down in the description. If you have any questions about this or want to discuss different things that we can try out to get the Wavelet to work or get even better results, then leave them down in the comment section. If you have any questions, leave those down there as well. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.